So I'm here representing Aerospike. How many of you have heard of Aerospike? Okay, got one guy in the front. Yeah, Jim, right. So Aerospike is a database company. And so what I'm going to talk about today is the kind of tech stacks that you might use to develop the kind of application that you saw on this stage earlier. I was talking to a fellow just out by our booth earlier who's got sort of the same similar problems, new products, and needs to adopt internet-type technologies to financial services. So the point that I'm going to make in this slide, I'll make the point, and you guys can go have coffee if you'd like, is adopting internet NoSQL technologies to financial services is one of the greatest areas of innovation. Whether that's taking Bitcoin, or whether that's taking next-generation analytics, or integration, or fraud, all of these patterns will require more data and a new kind of application development paradigm. Those paradigms were all created from internet companies. Now, here we are in Silicon Valley. When I give this talk in New York, perhaps it's a little more shocking to them that they might have to get off of SQL and get off of DB2 in order to use the power of internet-style applications. But that's essentially what I'm going to talk about today. Aerospike as a database has a couple of interesting properties. It doesn't support referential integrity. It's a NoSQL database. It does support Flash. So it gives you the properties of a RAM-oriented database, but with the cost of Flash. So if you need a 6 terabyte, 10 terabyte, 20 terabyte scalable distributed database, this is the kind of thing you'd use. A lot of folks start with Cassandra, come over to us once they see some of the numbers. But enough of the product pitch. Let's talk about databases and building these applications. When you talk to an older, large-scale company, the real key to bringing in a new technology, for those of you innovating, is this two-speed IT model, which is how Gartner talks about it. The best way to go in, as I've seen, is you say, look, you've got a business. That business is settlement of transactions. That business is retail. It's selling to your customers. Great. We're going to give you some new tools. The area of engagement, the area of customer 360, all of that needs to be additive to their old systems. You just don't go in and take out the DB2 system. You need a second tier or a tier on the side that is your new tier. That is the only reasonable way to try to innovate in these. When I'm talking about this to a JP Morgan, or those of you going up to the Bank of America Summit on Sand Hill this afternoon, this is the way you have to position it. You have to say the new thing, the innovative thing, is additive to your old business. We're going to change your business process, maybe. We're going to change your bottom line, but we're not going to take out your DB2 settlement engine or your X8 transaction system. So the application paradigm that underlies all of these kinds of systems is there is a very fast operational database. That's the red Aerospike type, but there's other operational NoSQLs out there. And then there's your own code. That ends up being the algorithms, the searches, the screen layouts that you have created. Imagine that the previous presenter, right, got new ideas about how to present data, what's useful in front of a customer. That's going to be your code. That's your crown jewels. Gartner calls this the algorithm economy, and the algorithms that your company finds is what you're selling. It's not just the data, it's the algorithms. So what you need under that is a very fast database and the ability to rapidly change what happens at that algorithm level. So this is the core idea. And secondly, you need a research analytics tier. Do not confuse these two tiers. All the internet companies that I have seen have split those two components for simple operational reasons. Analytics is a different beast, and it requires a variety of tools in your tool set. You need some HDFS. You need some SQL for ad hoc queries. You need big systems. You need smaller, faster systems. Most of our customers have nearly 10 to 15 different vendors in that analytics side. But when you take the insights and bring it over into your app, you end up in this operational realm where you need a system like this. Now, what's important is the innovation you create at the application level needs to use the tools that your team is familiar with and thinks are correct for your business. Now, no one asked the previous presenter, are you guys using Meteor? What's your back end? Are you Java? Are you JavaScript? But their team made some very conscious decision about that front end and what works. The fellow I was talking to earlier today, he's like, well, I need a graph database. What graph database do you support? And I said, well, which one do you want to support? You want Titan, you want Orion, you want Nuo, what do you want? And he's like, well, we looked at all of those, we ended up writing our own. That is exactly the internet pattern, where someone says, I am going to be innovating in that space about how I follow links, how I explore the graph, and they end up writing the code there. You shouldn't have to reinvent the back-end data store. So this is the pattern that the innovators are using to create these kinds of applications, and you should too. So to go into a little more detail, same picture, there's a variety of choices that you're going to have. That app server needs to be fast and stateless. Think about cloud development. In the cloud, you've got compute. And compute needs to be scalable because you don't know what algorithms and the compute load that they are going to create you need. Whenever I see a two-layer design, ignore the load balancer, you've got one for compute and one for data and a network hop in between. This pattern of tech stack is, I believe, key to these new environments because you don't really know at the beginning of a project how much compute you need and what kind of compute it is. Is it a GPU compute engine? Is it sort of a big compute engine? And what tool might you use? That is a very cloudy design because you can add in a few more stateless servers pretty easily. You don't have to deal with data motion. At the data layer, you want a fast, scalable, clustered system, which NoSQL systems are, whether it be Cassandra or Mongo or Aerospike or even HBase, that's a slower, larger version. What you want is you want a data layer. Now, an old trick was to try to push, and still a great trick, is to push compute into your data layer to avoid that network hop. And there is a place for that, but what I have found is separating the two of those gets you faster, more efficient application design. That's a key insight. So pay that hop once, pay it with a fast data layer and a fast application layer, but if you start pushing your compute into your data layer, you're going to run into a couple of problems. You're going to restrict the set of tools that you can use for your compute guys. When your compute guys come and say, but I need machine learning. Machine learning is the right thing. We've done some research. And you say, well, I can't, this database, I can't push machine learning into it. Oh, well now, you're in trouble. Whereas if you keep that separate, you will end up in a pretty good place. I've seen this over and over again because the innovators need to rapidly change what's at the application layer. They need to change their tooling sometimes. They need to bring new ideas to bear. And paying that network hop once is a suitable trade-off. Let's go through a couple of examples of all of this. So at Aerospike, we first found use in advertising technology. Pretty interesting space, underappreciated by some, don't know how much a lot of you know about it. Of course, this is sort of the area for it, right? Google's down the street and Yahoo's on the other side. Ad tech is now a market, and every ad slice is bought and sold in a 10-millisecond auction. An auction. Imagine if every security, instead of doing bid match, was resolved through an auction where it's not the fastest guy in, but it's the guy with the best price over a period. It would actually radically change the way financial services, the way that trading happens. But that's how they set up the internet, is internet advertisements occur in an auction. The key to being a player in this is to have the most compute and the best compute over the most data for the millions of auctions that happen every single second within, say, the North American market or Indian market or any of the large markets. So it's still real-time analytics. Do I want to buy this particular impression? Well, do I have a recent search term for this person? Do I know something about intent? Is this person's profile something that I have been asked as an advertiser to buy and I'm close to my deadline? Well, I'm going to push up the price, make sure I can get them. That's the kind of analytics these guys are doing millisecond by millisecond, and again, using that first tech stack. So that's how I know that this works for real-time behavioral analytics. Let's talk for a moment about trading and systems of record. The push in these systems, there's several different business drivers to improving and modernizing for trading and position systems of record. One is fraud. Just like in advertising, this system has fraud also. What I like to say is when there's money, there's fraud. And the new algorithms for trying to catch fraud are a bit more sophisticated than the old rules engines that you might have already have either in your company or through an outside provider. Now, fraud detection is done with machine learning. It's done by knowing the IP addresses of incoming systems. It's by looking at slightly larger a larger worldview in order to see the kinds of patterns that you need. The second thing is risk. Those of you who are involved in the industry know that risk calculations have needed to go from a 24-hour cycle to a minute-by-minute global risk evaluation, according to, first of all, regulatory constraints, but also simple survival of every business. Every executive knows, post-2008, that if you are any brokerage house, you're extending money on margin, you're a lender, and you could go out of business if you are not managing minute by minute the risk across essentially your lending portfolio, which is your customers. Those calculations become a lot easier if instead of trying to pack it into SQL, you use that other system that I talked about. The third thing, of course, is mobile. Mobile drives more views, it drives more people hitting their pages. The fourth thing is settlement systems got a lot more complex about 10 years ago. Instead of simply taking your position and settling it with a market maker, you have to split up. You've got parent-child relationships, you've got dark pools, you've got regulatory constraints of where you can trade those in order to get the best price and track it. All of those require an increase of speed at that front-end piece. Now, importantly, we're not talking about changing out the back-end system because that's where your regulation and tracking is. Fraud prevention, another case. I'm not going to walk through it, I sort of did that before, but you can see the same case. I need to bring algorithms to bear, and again, it's additive to the old system. In a particular fraud detection case, we did a simple system where we looked at how much money could we save compared to another NoSQL guy. What happens in choosing a Flash-oriented database is you get these things like, instead of $2 million in hardware, it's $1 million. So you can cover more data, and this becomes one of the core cost drivers in your business. So you get to do more interesting kinds of business too, and look at different business problems. So let's talk for a minute about Flash. I've only got a couple minutes left. Those of you who are not using Flash inside your data center, either in the cloud or in direct on-prem systems, are missing out. The world changed a lot literally last year with the advent of this thing called NVMe. NVMe is a standard interface over PCIe that allows the device makers to do what they do well and build hardware, and the operating system guys to do what they do and write great drivers. That was a significant technical barrier in the past. The guys who had the best driver writers sometimes weren't the guys with the best hardware. So you'd get devices that sometimes performed well but depended on versions of these things. This has made it much more like plugging in and driving your Tesla. There's fewer moving parts and people are doing different things well. Major manufacturers are also available. You don't have to go to something esoteric. The second thing is all of these systems are now available in public clouds everywhere. Every public cloud has a Flash offering. One of my favorites is Google Compute. And that's not just because my sister works over at Google. It's because the system allows flexibility, and it also is NVMe based. You can put a different set of devices per compute, and you can basically change some of the I/O characteristics. Amazon is also great. They got in a little bit earlier. I want to talk to you for a second about this thing called 3D X-Point. How many of you know about storage class memory? Okay, this is just a little teaser. I only got 30 seconds to cover it. Intel has come out with a new and super exciting, from a database company perspective, advance in storage. It is essentially what's called resistive memory, although they won't call it that. Instead of having little cells of bits like NAND does, or having magnetic spots on a rotational disk, they have this array. Reads and writes are faster. It doesn't suffer from the large block problem. and it is essentially DRAM-like, but it's persistent. This is something called Optane when it's in its disk form, or an NVDIMM package. It'll be coming out either this year or next. Aerospike's very excited about this technology, and we have Intel as an amazing partner for this. So it's not just about NAND, it's also about some of these new kinds of storage that are coming in the future that will allow you to use this kind of RAM-like speed through a variety of different storage mechanisms, also at different price points and density points. If you want to put together a 20 terabyte system, I'm going to recommend that you use NAND. If you want to put together a few 100 gigabytes, it's probably a DRAM system. When this comes out, we'll have a whole nother set of choices. Anyway, hopefully I've given you some food for thought about how to do application design and how to ingest some of these kinds of new technologies of internet development into the tech stacks as you innovate in financial services. So thank you.